Hello and welcome to 3D modeling video number 48. Let's continue on with modifiers. So last time we left off with the noise modifier. This time we have normal. This is a very simple modifier. You can use it to unify the normals or flipped normals. So you notice that when flipped normals is checked on, all the normals have been flipped, and now basically what this does is this flips the faces. So now the regular faces become the back faces, and the back faces become the regular faces. So it's a very simple modifier. Next we have optimize. Optimize, similar to multi-res, can be used to simplify your model. So as you increase the face threshold or the edge threshold, you'll notice that the model starts looking worse and worse. So once again, I would not recommend doing this unless you're doing this for background objects or objects that will not be deformed, like rocks and broken pieces of things, broken pieces of wood and metal and things like that. If you want to quickly optimize things for games, something important like weapons and characters, it's best to do it yourself. Or you can, however, use the optimize modifier on things like rocks and caves and those kinds of large organic things where the topology does not really matter because they will not be deformed. Next we have patch select and patch deform. So once again, that's working with patches, which I don't do. So if you convert an object to a patch, you will be able to use those modifiers. However, I've never really experimented with patches, so I'm not quite sure what they do. I found that polygons do everything I need them to do, so I've never really bothered to work with patches. Next we have path deform, which there is a better version of path deform in the world space modifier. As you can see right here, path deform WSM for world space modifier. So once I start teaching you guys about world space modifiers, I will cover the path deform. For now, just know that the path deform here in object space is an inferior version. We have the PenAttribute Holder, which is a custom modifier, which, remember, you can download all sorts of scripts and plugins for 3ds Max, and you can even download custom modifiers. This is from an artist named Paul Neal, and I will have a video later on how you can use some of his tools. He has some very nice tools that he offers for free on his website, so that's a good idea to use them. A lot of 3ds Max artists have their own custom tools. Sometimes the tools are proprietary tools used by a studio, which means that you can only get those tools by working in the studio, and sometimes some artists will offer them for free download. And whenever you see one of those, it's a good idea to use them. And I will have more videos about scripts and plugins that you can get for free later. But that was basically a better version of the attribute holder. Next we have the Physique Modifier. This is kind of an old, kind of outdated modifier. A better way of doing this would be using the Skin Modifier, but the Physique Modifier basically allows you to skin a character to a pre-made bone system. And I think the bone system is located, if you go here, let me see, under helpers or systems. Under systems, you have your standard systems, you have the biped, and you can use this thing with the Physique Modifier. As you can see, it's a pre-made set of bones that you can use to rig up a character, skin the character, and then you can animate the character. However, it's kind of an old system, and I recommend using the Skin Modifier instead and building your own custom bones. Next we have the point cache. Okay, so as you're doing animations, you are deforming the different models to do different things. And that can take up a lot of system resources, and it can cause your viewport to slow down, and it can cause your animations to play back slowly. So your animation bar is right here. As it moves, the animation goes forward, continues. And if you have something very complex happening on your viewport in your screen, then this can give you a very slow, choppy animation. You use the point cache modifier, and what that does is it will take the vertex position of your object as it animates, and it will copy that to a file, to like an XML file. If you use XML, that means you can transfer the information to different programs like Maya. But there's also a different format that 3ds Max uses. So basically, the basic gist of it is, it records the position of all the vertices of your object at all the frames, and it saves it to a file. And then you can simply load up that and have that be animating instead of all the different physics and cloth and everything else. So when you're working on animation, you have different simulations. You have physics, wind, cloth, explosions, soft bodies like human bodies, ragdolls, and all that. And all that stuff is happening in your viewport. It's taking up lots of system resources, all the simulations that you do. However, point cache will capture the vertex positions of all the objects at all different frames, and it will give you a very simple, quick, efficient playback without having to have all the simulations be working. So once I talk to you guys about animations and having physics and cloth and all that, the point cache will really come in handy. It's a great way of speeding up your animations and your viewport. Next we have polyselect, which is just like mesh select, just slightly different. You can use this once again when you want to have a modifier only affect a certain region of your model. You can use this. It's just like mesh select, just like edit poly. Next we have the preserve. This is kind of a strange one, but basically, if I take this object, I'm going to go ahead and select the top vertices, soft selection, just kind of move it up like this. Okay, so I've taken this sphere and I've modified it. If I apply the preserve modifier and then go to original, pick original, you can see that it still kind of keeps the changes in the vertices, but it kind of preserves the volume of the object. So this is before and after. You can see that it still keeps the upward movement, but it preserves the volume. And this can be useful in some situations when you want an object to animate, but you want it to kind of preserve its volume, its edge, the lengths of the edges and the angles of the faces in the volume. These are the preservation weights. So you can preserve the edge, the length of the edges, the angles of the faces, or the volume. It's kind of a very specialized modifier, but you can see that it allows you to animate but preserve certain characteristics. So it's a modifier you might find yourself using rarely, but it still has its uses. Next we have projection. This is what I'm teaching you guys about with normal maps. So if you want to know how to use projection, you just go ahead and look at my videos on normal maps. Next we have Pro Optimizer. This is very similar to the Optimize modifier, except sometimes in 3ds Max you'll have a Pro before the name, and this basically means that it's a newer version of the modifier. But of course they still give you the old version if you've gotten used to it, because as programs come out with new features, they don't immediately remove the old features, because people have become accustomed to those. They know how those work, and they still want to save those. A lot of times those kinds of features in the program, those kinds of tools and features are called legacy items, which means they're kind of old and outdated, but people want to still use them because they've been around for a long time and people have, you know, developed various tips and tricks for working with those, so that they don't want to immediately remove those. Anyways, you simply click on calculate. The more complex your object is, the more time it will take. Then you can decrease the vertex count or the vertex percentage. So this is similar to using decimation in ZBrush. And as you can see, it works better than optimize. I'll give it that. It works better than optimize. So this is actually a pretty good way of quickly simplifying your models. But remember, once again, as always, only use this on models that don't deform, like rocks, broken objects, anything that won't bend or move or won't be affected by wind. This would be a good optimizer. So as you can see, it keeps the silhouette, the shape, but it greatly simplifies it. And of course, when you're optimizing your scene, which means that you're trying to reduce everything that you can to increase performance, then what you would do is you would kind of zoom out and you would ask yourself, in a regular gameplay or in the in the final project, how far away will this object be to the camera, right? If it's going to be this close to the camera, you don't want to apply this modifier. However, if it's going to be like this far away, you can go ahead and decrease the amount of vertices to this, and that will not have much impact. So that's how you go about using it. Next we have the push modifier. This is a pretty good one. It basically pushes the geometry outwards. So if I apply push, it has one parameter, push value. It will go ahead and push it out or in. So it's similar to scaling, but it doesn't quite work like that. So if I apply a show modifier, give my object some thickness, and I apply push, it will kind of push it out and make it thicker. So it's quite useful for getting a part of your mesh to be thicker than the rest. Let's say you're working on a piece of armor, right? Let's say this is a character's like leg or something, and you're working on a piece of armor. What you want to do is you go ahead and select this, right? And I want to go ahead and detach this as a clone. And now, so this will be the character's armor now. But I don't want it to be too close to the original geometry, so I'll go ahead and apply push modifier, push it outwards, and now I can begin working on the armor because now there's some distance between the person's body and the armor. And now I can begin modeling some armor. So push is very good for getting some thickness in your models. Next we have Quantify Mesh. This will add some quads to your mesh. Let me try it on this right here. You can see right now there's no quads on the top or bottom. The Quantify Mesh modifier can be very chaotic. It's mostly used for getting some very quick, cheap results, but it's not a permanent solution. So let's see. Quantify Mesh. Okay, so you can see it has gone ahead and applied some quads to the mesh. Here you can change one setting, which is the quad size. The higher this is, the larger your quads will be. Well, you can see it's not giving me quads right now. I think this modifier might work better if you're working with an edit mesh object. So let me try converting it to an editable mesh. Let me go ahead and try it now, see if it works better. Okay, there we go. So I think the Quantify Mesh modifier works much better with meshes than polygons. Well, that should be obvious because of its name. So you can see it basically adds some quick quads. You can see it's not perfect. This is not really good topology, but it's more of like a start. It's a good start to your modeling. and then you would go ahead and clean it up further. But you know, it's always best to do it yourself if you can. One solution, one reason you might want to do this is, let's say you have a text. So right now I'm using spline to create this text. I'm going to go ahead and decrease the interpolation. I will go ahead and cover splines soon. So basically, then I will apply an extrude modifier. Okay, so right now I have an object. I have an object with a ton of n-gons. This is all just chaotic. With just one polygon here. And let's say I want to quickly apply some quads. Let me go ahead and convert this to editable mesh. And now when I apply Quantify Mesh, you can see it quickly adds some quads. This is before and after. Before and after. So it's very messy, but it's not really designed to be clean. It's designed to give you some quick quads to work with, and you can go on from here. So that is what the Quantify Mesh modifier is used for. And remember to turn your object into an editable mesh before you apply it. Next we have reactor cloth and reactor soft body. So reactor is the system that 3ds Max uses for physics. So if you've ever heard of like Havoc physics, that's a physics engine used in various games. Reactor is what 3ds Max uses. That is its physics engine. And once I cover physics, I will teach you more about this. You have cloth and soft body. Next we have the relax modifier. And this is basically like the smooth tool in ZBrush or Mudbox. It's used to smooth out your model. So I have this box here. It's got these hard edges. If I apply a relax modifier, you can see it becomes a lot more smooth, and you can have a different value, and you can have multiple iterations, which means that with each iteration it will relax it by 1. So the more iterations, the more relaxed it will become, until it's completely lost its sharp edges and just become almost like a sphere. So that's the relax tool. You also have the relax tool under edit poly. So it's the same thing. It's just that it's a modifier, which means you can animate it. So there you go. Next we have the ripple tool. Let me go ahead and try to use this plane to show you that off. That's a very self-explanatory modifier. You just use it to add ripples. You have 5 parameters here: amplitude 1, amplitude 2, wavelength, phase, and decay. Okay, so it's giving me this. Let me see. Okay, so now I'm going to go ahead and decrease the wavelength. Let me actually go ahead and make my plane more complex so you can see the effect better. So here we go. Just modify the settings until you get something that looks good. So basically, let's do that. Let's go ahead and lower the amplitude. So there you go. So you can have a basic animation where the phase basically loops the pattern. So let's try some quick animation. Let's go to frame 100 and set the phase to, let's say, 10. Alright, now let's see our animation in progress. So there you go. It's a very simple modifier for quickly adding this kind of ripple effect.